So after you watch the part 1 of this video, so proceed this part 2, we'll be having some examples. Okay, so x plus 2 over x minus 3 is less than or equal to 0. So again, transform right hand side to 0, and since right hand side is already 0, so we're already done with this. So simplify. Apparently our function is inequality is already a simplified expression. Next is to separate numerator. So x plus 2 is equal to 0 and x minus 3 is equal to 0. So x will be negative 2, x will be positive 3. After that, so will be we would like to have a number line. Okay, so I think I'll be using negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, okay, 4, and 5. Okay, so I'll be drawing a border at negative 2 and at positive 3. So we'd like to name this one as A, B, and C. And we would like to prove the argument of x plus 2 over x minus 3 is less than or equal to 0. Okay? Let's have this. So let x be equal to, I'll pick a number, any number at region A. So this will be negative 3. So negative 3. So this will be negative 3 plus 2 over negative 3 minus 3 less than or equal to 0. So negative 3 plus 2 is negative 1. Negative 3 minus 3 is negative 6. Less than or equal to 0. So this will be 1, 6. Less than or equal to 0, which is not true. So this will be a false argument. So 1, 6 is not less than 0. So you will not be having a value lying at region A. So let's try to prove region B. So pick a number. So I'll be choosing 0. X is equal to 0. So 0 plus 2 over 0 minus 3 is less than or equal to 0. So this will be 2 over negative 3. And negative 2/3 is less than 0. So this will be true. Okay? And letter C. So I'll be drawing a line here. So limited only to this border line because the border line acts as the shield, no, or the boundary line. Okay? So C. So I'll pick, I think I'll need to pick number, so I'll be choosing 5. So 5 plus 2 over 5 minus 3 less than or equal to 0. 5 plus 2 is 7. 5 minus 3 is 2. Apparently, this argument is not true. So this will be false. 7 over 2 is not less than 0. Okay? So our interval will lie on this region B only. Okay? And however, I have negative 2 and positive 3. Would be negative 2 and positive 3 will be included to the solution. So let's try to prove. So if x is equal to negative 2, so this will be negative 2 plus 2 less over negative 2 minus 3 less than or equal to 0. So negative 2 plus 2 is 0. So this will be 0 less than or equal to 0. And 0 is equal to 0, meaning to say negative 2 should be included. No? It should be included. Okay? If x is equal to positive 3, so I'll be having positive 3 plus 2 over 3 minus 3 less than or equal to 0. So 3 plus 2 is 5. 3 minus 3 is 0. And you cannot divide again a number by 0. So 3 should not be included to the solution. So I'll be using an open circle to indicate that the values will be limited only until until number 3. Okay? And it also exclude 3 as the solution of x. Okay? So name this using interval notation. I'll be having bracket, because that is a solid circle, -2, comma, +3, I'll be using parentheses beside 3. So it means 3 is not included. So -2, comma, 3. So another example. So 2x minus 5 over x minus 5 less than or equal to 3. So again, transform this wherein the right hand side is 0. So simplify. So we already simplified the answer. Now separate the numerator and denominator. Okay, so we have 10 and 5. So I'll be drawing a number line. So 10 and 5. So I think I'll be using 11. Okay, so I'll then draw a borderline at 5 and at 10. So this will be A, B, and C. Now prove the values on each region if it is true or false. So I'll have this as the simplified expression. So I'll be working on this expression, no? So this will be, I think I'll be using x is equal to 0. So this will be 10 over -5. So less than or equal to 0, and this will be -2. Okay, and -2 is less than 0. So -2 is so 0 or values at region A will be included. So I'll be having an arrow here. Okay, next is prove letter B. So I'll be using, I think I'll be using 9. So this will be -9 plus 10, okay, over negative 9 minus 5. So -9 plus 10 is 1. 9 minus 5 is 4. Less than or equal to 0. And this is not true. So 1/4 is actually greater than 0. So this should be false. Okay. Lastly, letter C, I'll be using 11. So this will be 11 plus 10 over 11 minus 5 less than or equal to 0. So -11 plus 10 is -1 over 11 minus 5 is 6. So less than or equal to 0, and this is true. So our values will lie on A and C. Okay? And B, okay, so we don't have any values at B. So however, we don't know if 5 and 10 is included. So we just need to prove. So if 5 is included, let's check. So -5 plus 10 will be 5. 5 minus 5 is 0. And we already know that this is not applicable. So you should place an open circle here. And at 10 will be 10. And 0 is actually equal to 0. So we should include 10 on this set of values. And using the knowledge in interval notation, we could name this one. So from left to right, so this will be negative infinity. So negative infinity, I'll be using parentheses, comma, 5. And 5 is not included, so this will be parentheses, union, 10. I'll be using bracket because it uses a solid circle indicating that 10 is included into the set of values. And this will be positive infinity indicated by this arrow. So positive infinity, comma, parentheses. So this will be the set of values or the interval values of x in this expression.